Okay, so the level is out. I'll put the ID up there. Hang on. There we go. Um, this took a long time to make, so yeah, I'd really appreciate if you guys went and played it, but you know, you don't have to. Anyways, uh, this video after the level showcase, I will be explaining all of the scientific concepts and showing some rough notes and stuff that were used to make the level. So enjoy. Time for the science. So, if you don't like science or math or real life or touching grass or having friends or doing anything with your life, then please by all means skip to the lore section. Otherwise, please stick around because I will be explaining and yapping and not doing a non-scripted thing because I am really bad at making videos. So, yeah, enjoy.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Alright, this is gonna be really awkward because I'm holding my phone with one hand and a pen with the other one. So yeah, why is there? Forgot I put that there actually. Okay, level editor. Oh shit, level editor. Recording file. Anyways, time to explain how this works and goes down. Okay, so you see the moon here, right? So the moon is like this. You have a circle here, and that's a bad circle. Then you have the Earth. Okay, the moon goes around the Earth. This is also really bad. Oh my god. Oh, that's a horrible orbit. Oh no. Sorry. Scrap. Alright, so after our first try, we have. This is a horrible representation. I feel so ashamed right now, but it doesn't really matter. So the moon orbits around Earth, right? And the thing with this is, it's not exactly like the moon spins along with the Earth, but they spin different directions. The moon is quite literally facing the Earth the entire time that it's orbiting. So when you look at the moon like this, bad. This is really bad. Oh god, my artistic skills are down the drain, as you can clearly see. This is how the moon will look, right? And the only reason it goes like shades different, whatever it is, stages of the moon, right? Over time, like it'll go darker and darker and darker. That's because the Earth is rotating, not the moon. The moon, one face is always facing the Earth. However, the other side is reflecting the light from the sun. That's why sometimes you can see it, other times it's dark here, right? Not if that makes sense. I'm gonna pretend you guys nodded, but yeah, I'm so bad at this. What do I do? And this is where we come to the first intentional mistake that I left in the level. So in my level, there is actually something where it kind of just doesn't rotate, or like it's not facing one side of the Earth at all times. Instead, when it comes around and rotates behind Earth, it's actually weird. It goes and doesn't do the thing. So like I'll show you. It's like this. Hang on, let me like open it here. No clip. No clip was used. See, look, the moon goes behind, but the Earth doesn't rotate alongside it, right? You guys saw that, right? I'm hoping you guys saw that. Anyway, so a few of you might have noticed this thing here. This is, anyone know? It's gravitational field equation, or gravitational field intensity equation for the moon. So what we did for this is, I'll write it out. Okay, so it's gonna be really weird. The gravity of the moon is equal to the gravitational field constant. I'm not even focusing the camera. Okay, gravitational field constant times the mass of the moon. So that's mass of the moon. Oh my god, not moon. Moon. Oh my god, I'm having a seizure, bro. There's like a few hours left till the Space Gauntlet contest. And that's all divided by the radius squared. Okay? I'm having a brain fart. Okay, so the gravitational field constant is 6.67 times 10 to the power of negative 11. I think it was Newton time meters. Let me check. Alright, I figured it out. Got some old notes here. Hopefully my name wasn't in on any of those. But anyways, so it is newtons times meters squared per kilogram squared. Okay, and then you're multiplying it by the mass of the moon, which is, let me see if I can pull it up somewhere. Oh, in the level. Whoa, 7.348 times 10 to the power of 22. 7.348 times 10 to the power of 22. And that's going to be kilograms. Squared? Man, I can't. Okay, I keep forgetting. Well, whatever. No, because we're gonna get newtons per kilogram as the answer, so it doesn't really matter. It's been a while. Took physics last semester, so it's kind of out of my brain right now. And then the radius of the moon, which is going to be. Oh, it's on the level again. 1,737.4 meters squared. Wait, not meters squared, what the hell? Why is there a squared there? Do I have to remove that now? Wait, I'm confused. 1 second, the physics is not physicsing. Yeah, I'm just really tired today. So it turns out it's not meters squared, it's meters. This entire thing is squared. Alright, you see how the meters becomes meters squared, it cancels this, and this cancels with this. So you get, as the answer, you get 1.625 newtons per kilogram. So on the moon, it takes, so let's say you're trying to move a box that weighed 1 kilogram. Oh my god, I can't draw the damn moon. So you're trying to move a box here, and you're trying to lift it up, right? It would take 1.625 newtons to lift 1 kilogram. To lift this 1 kilogram box off the moon. That's how many newtons of force it would take to lift it up. Okay? Comprends? Why am I speaking French? It's the banned language of the Daily Dose of Geometry Dash, guys. What am I saying? And another thing, why is my camera so blurry? What the hell? Stop blurring. Okay. A really cool thing that I learned and actually put in the level is that when you divide the gravity of, what was it? Let me check. The Earth, yep. It's just sometimes I mess up the order. Gravity of the Earth over the gravity of the moon, right? So this is going to be 9.8, I think 1, I forget, I don't know. Newton. Oh my god. No. Oh, it's so hard writing while looking at the phone. It's kind of over 1.625. You get an answer that's really close to 6. So wait, it's gonna be like the curve equation, not equation, equal sign. 6. You guys can see that, right? Is it, like that's. Whoa. Okay. Anyways. Yeah, honestly, that's pretty much it. I don't really know what to say for the first part. I did lower the gravity for the entire first part just to show that we're on the moon. Otherwise, it wouldn't really seem like we're on the moon, you know? Gotta make it immersive. Also, look at these triggers. Hang on, let me open up the effect lines. Gotta emphasize this as much as possible. Okay, so I am extremely organized. Oh, it's not even rendering all of them. Yeah, it's kind of funny. Yeah, anyways. For the next part, UFO, nothing too special here. The planets, which actually it is kind of a special part. I think one of my favorite parts in the level, other than like the ends, like this part here, I like that part because it's like cool. But this part is kind of like to build the plot in the story, so I'll come back to that part. But the planets, let me try and like show you again. So this is the moon part, which we already went through. Yeah, it's kind of okay. So this part, they actually orbit around, and once you get past here, you get to see what they're orbiting around, which is a black hole. And once it orbits around, since the black hole's gravitational field strength is so strong, it always orbits around and around, and it gets closer and closer until it like lands in the black hole. Obviously, that's not the case for everything because some planets or some stars even are able to orbit around a black hole without completely like succumbing and falling into the black hole. But that's mostly because they're like it's at a specific place where the black hole and the sun are equally distant apart that it won't pull it too much, but it still has a pull on it. So that's how gravity works. Anyways, what's the next thing? Oh yeah, there's also statistics about a black hole here. This is the nearest one to our solar system. That's also one of the smallest as well. That this is all true. This expands into infinity because, yeah, it kind of like does that as an animation thing. I'll try and show. So see here. So yeah, it does go to infinity because that's that's like the gravitational field attraction of the singularity, but it kind of decreases rapidly. Not rapidly, it decreases really slowly as the black hole, as you get farther away from the black hole. So yeah, that's that part. This part's next. I can't see what the hell is. Can't see what's happening in this part. I don't know why I cut the recording here. Okay, so I paused right at the jump orb, which is probably not a great idea, but the black hole's there. It's the same one, Gaia BH1. Let me just, and I missed it, but that's fine. So the black hole here, you'll notice there isn't like some kind of disk around the middle, right? But that's because you're close enough to the black hole where it's not really visible because it's warping space-time around it. So light always will bend so that it's going around the black hole. Correct me if I'm wrong. I did do a lot of research on it, but you know, the internet's weird and everything. But you know, it's kind of like, let me try and draw it out again. 1 sec. So let's say that this here is our light. Really great drawing of light. I know. Let's draw a flashlight actually. Guys, I am a true artist. Trust me. Holy. Oh my god, I'm cooking there. That's it's a switch there. Okay, so there's light, and it's trying to go right there, across, right? But it can't do that because the gravity is so strong, it pulls it inwards, but due to redshift and other things that I'm too lazy to explain, it goes around because the black hole kind of bends space-time, due to a theory. Well, it could be because of wormholes, could be because of anything actually, but the singularity kind of breaks the laws of physics in a way, so that whatever the radius of the black hole is, everything looks like it's going around it when it's all falling into it. So you can't see a black hole. You'll see a warped image, or like a warped visualization of something, like what's behind it, and you'll see around it, that's the light accretion disk, goes around like that. Light accretion, it's kind of like the light gathering around it before it goes into the black hole, because the black hole will consume too much and it can't consume that much all at once. So what it does is the light orbits around it just like a planet or star would. So I find that really cool, and I decided to put that in the level. So you can see this also is not completely accurate, because there is, oh my god, there's light going across it. Well, it could be accurate. My research did not prove that or anything, so whatever. Yeah, you then fall into the black hole, which is also, well, I think it's cool. And that transition's not accurate. So, before we get into the next part, let's just explain what redshift is, because the transition that I made is not accurate. That part right there, that transition there, not accurate. Well, the speed of light is, because the speed of light is the speed of light. Anyways, so there's something called redshift. As you get further and further away from something, it kind of gets more and more red, because the color, well, according to the wavelengths of what we can see as visible light, blue is over here, red is over here, and the frequency gets more and more and more and more and more and more. I can't draw waves properly because my drawing skills are superior to everyone else's in this world. But yeah, it's kind of like that. Blue's over here, red's over here, and eventually you can't see it anymore because the wavelength is too big, right? So that happens as we go farther and farther away from a star. So we obviously can't do this in real life. Well, we can, but it'd take a while, because we live, like, everything that we see is too close together for us to observe. But the stars that we see in our night sky actually do get more and more red the further and further away they get from us. So yeah, that's pretty cool. This part here is this part's like theoretical, because this is like what could be the inside of a black hole. You kind of like see it, but like this is not the singularity, obviously, because singularities don't look like this, or we don't know what they look like. But this is kind of like what the exit of a black hole is. That's like you're already in the wormhole, but you're passing through the wormhole, and that's what it's like. So normally you'd be spaghettified, because as you get closer and closer to singularity, you go like, it's like this, and then you go like, and then you just die because you got compressed to like a thin noodle that's the size of like infinitely small. So, you know, fun stuff, fun topics. I love talking about that. Where's my mouse? I can't see my mouse anymore. Okay. Oh, forgot. No, okay. But anyways, yeah. Same thing with that one, except I kind of like made it so that it filled in a bit, like that, so that it could show the inside. Bro, I'm just yapping. There isn't even a script for this, man. I'm just explaining what I find as I'm not explaining what I find. I already made all of this, but you know, I'm explaining everything. And okay, this part I think was probably my best part ever, because of all the planet art. So, right here, this wormhole, oh my god, it's so bright. This wormhole right here, I made it look like a sphere, because according to Interstellar, wormholes look like spheres because it's like a circle passing through space, but it's like a sphere because it's like a black hole almost. So I'm not explaining this too well. But anyways, here's some cool planet art. And here's some facts about Saturn. It has a lot of moons, which I find was surprising. And let's find Jupiter. And some stats. And it zooms in here because asteroids are definitely not this big compared to the scale of Jupiter. But, you know, stuff be stuff, you know, obviously. Asteroid belts, there are some facts in there, but you can read it for yourself. I'm not gonna go and play the level again. This is Mars. Where's my stats? Mars, planet number 4. 2 moons, which are Phobos and Deimos, which you probably know, or hopefully know, if you pay attention to the leaderboards of Geometry Dash. There are 2 levels called Phobos and Deimos. Phobos is no longer on the leaderboard, but it doesn't really matter. It's cool detail that... Oh. Yeah, you guys got God, bozos. And I hid in Among Us because Earth has living people. And Venus was interesting, actually. Venus was interesting because this is like what it looks like with its atmosphere. And I just wanted to show what... Wait, what? Oh, it's an area fade. Sorry. How do I get rid of this? Yes, I can. Okay, so... What is... Bro. Okay, so there. That's what it looks like without the atmosphere compared to with the atmosphere. So without the atmosphere, it's like a volcanic, hot, really bad place. You can cook an egg on its surface in like, I don't even remember, it was like under a minute though. It's like super fast. There's some stats about Venus. No moons. And Mercury, there are no stats. Oh my god, that's a bright particle. But this is my art Mercury. There are no stats for it, but know that this side here, it's blazing hot. I don't know the exact temperature. This side is freezing cold, like negative... I think it was like 120 degrees. I'm probably wrong about that too. That's like, no wait, that's way too low, bro. What the hell? Okay, well, anyways, yeah, that's that part. And the last part, this part, oh, it's empty as hell, but the sun, when it explodes, or when it goes supernova in 5 or 6 billion years, it forms a white dwarf. Well, I know this, well, should know this, because our sun is too small to form a black hole. It's kind of tough to explain, but I'll try to explain anyways. Our sun is like this, okay? The sun we need to make a black hole is like this, okay? Like that's the comparison, okay? That it's like really small compared to other suns. So when our sun explodes or supernovas, we went kaboom. It forms like a white dwarf, which is a star composed of neutrons. Everything gets so compressed that it forms a star of neutrons, and while it's in the process of exploding, it will sadly destroy the first 3 planets of our solar system, which includes Earth, guys. So maybe in the next 5 to 6 billion years, we should leave our planet. It might be an idea worth considering. But other stars, when they go kaboom, they can either form a neutron star, I believe, or they'll form a black hole. So they'll either collapse like this and form a singularity with a black hole. I'll do the accretion disk, whatever. Or they'll explode and reform a neutron star, I think. Yeah. This usually mostly occurs with like blue or red giants. Not exactly our sun, which is like star. Yeah, I'm yapping. Low-key yapping, guys. Low-key yapping. But yeah, when the sun explodes, I'll play through it. Hang on. Alright, we're back. So, you see this? Notice how the white dwarf's here, but what the heck is this? Surrounding it, right? That's actually gas, but I couldn't really make a particle because I'm not that good at this game. So I couldn't really make a particle accurate enough to describe what the gas would look like. But this is similar to what it would be like. Not really. It's kind of inaccurate, but whatever. Hang on, I'll show you. So that's a 3D transition that I tried to make. It's really bad. But gas will go around it and it'll actually contribute to the white dwarf's mass, which I find interesting. So it's kind of like how gravity works. I'm saying that a lot, but that's a quote from Interstellar. It's gravity. You know, it's gravity. So you have your sun, or white dwarf. You have this madness of gas, right? Over time, the gas will condense and form a bigger star. See how it's like a little bit bigger? That's how it works. Sometimes, if the explosion is large enough, it can condense and form other elements, sometimes even solid elements. And that's somewhat how plants are made. That's how they were made with the Big Bang as well. the elements just kept condensing until it formed denser and denser elements, and then it became solid. Alright, let's keep going. Let's see how far I can get. Oh, the background disappeared. Wow, buggy editor. And I'm gone. Okay, whatever. So yeah, it's there, and the ending transition, it kind of explodes. Well, not explodes. Flashbang. Jeez. Yeah, well, it in the end, the sun expands, which isn't logical, so that's also inaccurate. Another thing, hang on. Alright, here. So, this is completely inaccurate. Do not trust this transition at all. You wanna know why? It's because light does not form straight lines when you go that fast, right? Because when we're reaching the escape velocity of a black hole, which by the way is the speed of light, if you didn't catch on to that, when we're reaching the speed of light, we're going like really fast. My notes look so weird. Oh my god, what am I drawing? Anyways, so what happens with this is light goes really fast, but it becomes a blur. You don't see lines going like this or like this. You don't see lines of light going by you. It's gonna be all one big blur, right? You're not gonna be able to see what's in front of you. That's how crazy the speed of light is. It's like so much faster than anything we've ever conceived of. So I think that's really cool. And yeah, I think that's basically all I wanted to cover about the level. If you guys have any questions about any other stuff that appeared in the level, then go ahead, by all means ask away. I am here to answer any questions and stuff, and if I did anything wrong, please let me know in the comments. I'm not great at explaining my thought process, but yeah, thanks for watching this part. So, small disclaimer here. A lot of thought went into this level. In fact, most of my time building it was outside of the level. I have a lot of research tabs that I was using on the browser and stuff. Yeah, I don't really know. So the 126 hours that I spent in the editor is probably a lot more than 126 hours. Another thing, this is not a video seeking pity. I am moving on from what happened in my life, but this video is rather something that I wanted to let out, but never had the chance to before. And thanks to this Gauntlet contest, I can now open up a bit. I don't know. Yeah, so November 2023. This is a bit of a story here. My grandpa fell terminally ill. He had leukemia and was unable to produce his own blood because the cancer cells had got into his bone marrow. And then on December 28th, he passed away, which he actually passed away quite peacefully with a smile on his face. It's something that I never forget. I always hold it in my mind and in my heart. And the reason I'm telling you guys this is because I'm dedicating this level and this video and every important thing that I do in my life from now on to him, because there isn't really anyone else in my life that I could endlessly talk about science and math with and who would actually respond and keep it interesting. My grandpa did all of that and was basically my best friend. So thank you guys for watching. Go play the level, and yeah.